Yeah, we can go over test review questions. Now, Stuart asked me to go over the word problems, so I'll probably start with those, if that's okay with you guys. So, and then we can, once I get through those, I can go over any other one you want. Just tell me which one, I'll do it, okay? So I'm pretty sure at this point we have covered every kind of problem type, you know? Okay, so here it is. This is number 45 from the test review. It says, Mrs. Boyd has a desk full of quarters and nickels. Boyd has quarters and nickels. All right. She has 18 coins in total. All right. And they're worth how much? They're worth $2.50. So then the question is, how many coins are nickels? So how should we do this? Yeah, and if I think I'll mention again, if you complete your the review sheet and give it to me. Now, if you didn't want to print it out, if you want to write out the solutions on separate piece of paper in order, I'll also take that. That's also fine. So, what do you guys think? What should we need to invent some we could use Q and N for the variables, right? Number of quarters plus the number of nickels. What's it equal to? Well, no, but then this is just the number of quarters plus the number of nickels, 18, right? Now, if I want to do it in terms of cents, we've got 250 cents, right? 250 cents is $1.50, right? How many cents does a quarter give me? 25, right? So 25Q. How many cents does a nickel give me? 5, right? So 5N. So there's two different schools of thought. Some people would write 0.25Q plus 0.05N equals to 2.50. So if you wanted to write the equation in dollars, that's what the equation looks like in dollars. I like to think in cents because, decimals are a pain. And of course, you can multiply the parenthetical equation by 100 and get what I got. 25Q plus 5N equals to 250. Then what? Now we got two equations, two unknowns, so we can solve this thing, right? I think I'll use substitution, yeah? So would you guys want me to solve for N or solve for Q? Okay, so this gives me Q is 18 minus N. Then I take this, right? And I plug it up in here, and that gives me 25 times parentheses 18 minus N plus 5N equals 250. Now, 25 times 18 is 450, I think. So I've got 450 minus 25N plus 5N equals 250. And that gives me what? 200 equals what? So this gives me a minus 20. I add it to the other side, I get 20N. So subtract 250. 450 minus 250 is 200. And then this, when I bring them to the other side, gives me 25 minus 5, which is 20. So if you like, we can make another in-between step. This would be 400 and, 450 minus 250 is equal to 25n minus 5n, which then gives you this. So what's n equal to? 10? Yeah, 200 over 20 is 10. So n 200 over 20. So how many nickels were there? There were 10. So how many coins are nickels? 10. So how many quarters did we have?
8.
So, by the way, Q equals to 8. And then check your answer, right? So 8 quarters gives me how much? $2. 10 nickels, 50 cents, $2 plus 50 cents, $2.50. Okay, makes sense. So all of these word problems, you want to, my strategy for any word problem is to write the word problem down myself. Writing the sentences out make me stop my brain down slow enough to understand what the sentences are saying. In the process of doing that, I hopefully understand what the question's asking, right? And then I also, at that point, I'm trying to identify what variables are in the problem, right? I give labels to those variables, and then hopefully it gives me a math equation I can solve. Let's do the next one, yeah? 47, that was 40, oh yeah, 46. This looks like a speed problem. Speed of a stream is 4 miles per hour, all right? Boat travels 98 miles downstream, all right? In the same time, it takes that boat to travel 49 miles upstream. What's the speed of the boat in still water? So admittedly, this one's a little bit trickier, I think. So let's see here. There's two situations, right? You've got the river, right? And it starts and, right? And how far is that? 98 miles, right? And on the other hand, the other situation, we have the start, the end, right? And it's 49 miles upstream, right? So let's see, the stream, I'm assuming that the water goes this way, right? Right? Now, the boat if it was just floating on the river, right? What would the speed of the boat be? Just the speed of the river, right? So we're assuming that the river has, this has, stream of speed. We should give it a name, VR for the velocity of the river itself, okay, like the speed of the river. So if the boat was just sitting there, right, and it wasn't doing anything, it was just floating along, it would do what? It would go speed VR down the river, right? Right, speed of the river. Now, if we just had the boat just sitting here and it didn't have any motor on, could it go upstream? It could not, right? That wouldn't even be possible. Okay? So here's my boat. So, but it doesn't just sit there, right? It's got some motor going, right? And so it has some kind of, what's the word? Speed relative to the water it's in, right? So we could talk about the boat having speed. What's the actual speed of the boat? The speed of the boat, in this case, is the velocity of the boat itself plus the velocity plus the speed of the river. All right. So in this case, whatever the intrinsic velocity the boat motor generates, like if it was just in a lake going across the lake without current or anything, whatever that speed is, right? Maybe it goes 30 miles an hour. If the river is going 10 miles an hour this way, then the boat would be going 40 miles an hour because it would get the 10 miles an hour from the river going where it is plus the 30 miles an hour of its own motor, right? In contrast, if the river had speed 10 miles an hour for the sake of discussion, and the boat had 30 mile per hour, motor, it could generate 30 miles per hour relative to the water, then it would only be going 20 miles an hour upstream. So in this case, the velocity of the boat goes relative to the shore is the velocity of the river minus the velocity of the boat. See, because the boat is going opposite. The velocity of the boat is going this way, whereas the velocity in here is going that way, right? So when the boat's velocity relative to the water is in the same direction as the velocity of the water, they add. When they're opposite, they subtract. All right? And so in both cases, this is the speed of the boat relative to the shoreline. And in both cases, we have velocity times time is distance. So in situation 1, we have 98 is equal to the time, whatever time it takes, right? Times VB plus VR. And it says in that same time, because this is distance is time, distance is time times speed or times time velocity. And on the other hand, we have 49 is equal to that same time times what? Times VR minus VB. Let's see here. Oh, I'm an idiot. What else do we know? I'm completely ignoring it. Is the speed of the stream arbitrary? Is the speed of the stream arbitrary? Is it not known to us by the problem? It says it. I completely forgot about that, right? So we know that VR, and I changed the stream to a river. My bad. Is 4. So what do we have? We've got 98 is equal to the time we don't know, right? The velocity of the boat, we don't know that, plus 4. And on the other hand, 49 is equal to the time we don't know times 4 minus VB. Okay, so the way I would solve this would be, I don't care what the time is, right? So since I don't care what time is, I eliminate it. So I solve both of these for t. This says t is equal to 98 over VB plus 4. This says t is equal to 49 over 4 minus VB. Right? I can solve both of those for t. So then I get 98 over VB plus 4 equals to 49 over 4 minus VB. How do you solve an equation like that? I think what we want to do is we want to cross multiply. So the way I would solve an equation like this would be to trade it for the following equation. 98 times 4 minus VB equals to 49 times VB plus 4. Does that make sense what I did? What I did was I multiplied I multiplied the equation by 4 minus VB, so they cancel on the right-hand side and they stay on the left-hand side. Then I multiplied the equation by VB plus 4, so that cancels on the left-hand side, but it stays on the right-hand side. Another way to say this is, whenever you have the pattern A over B equals to C over D, what you can do is trade that for AD equals to CB. This is just a good rule of thumb. It's a good algebra step to know. It's called cross-multiplying. Now what? Now I've got one equation in VB, right? So multiply it out, what happens? 4 times 98, 392, is that right? You can check me on that. Do you guys get 392? Yeah. Okay, good. 49 VB. What's 4 times 49? That seems like 196. Thank you. And so then, what's this give us? This gives us 392 minus 196 is equal to 49 VB plus 98 VB. I guess that gives me 196 equals to what? I might have done that wrong. 186? 196. Oh, yeah, okay. And then what's 49 plus 98? All right. So if I didn't make a mistake, VB is 196 over 147 miles per hour, which you can find a, man, that feels wrong. That's 0 point what? 0. That is 3. That's 3/4. Yes. Oh, then it feels more right if it's 3/4. If it's 3/4, it starts to feel right. "12 miles per hour." What the what? 12. Oh, what have I done? Well, let me get further away from it. Well, huh. Well, the answer says 12 miles per hour. Interesting. Let's see if I can find a problem in the, let me see if I can find an example in the book which is just like this one.
What page you do 98 divided by 4 and 49 divided by 4? Then whatever you do there, subtract it, and it gives you 12.
No, so I'm sorry, you did what, 98?
Do 98 divided by 4. That gives you 24. And then 49 divided by 4, which gives you 12.
Well, 12 point something.
12.25.
Uh-huh.
12
5.
Yes. Never mind.
24.5, yeah.
Yeah, never mind. Scratch that.
but why would those divisions be be relevant? I mean, all right, let's see here. Give me a second here. Let me find there's got to be a problem in this. All right, here's example 6. It's about boats in water. See if we can work this and decide whether or not. See, so maybe we'll see our approach was maybe there's something wrong with my approach. All right, here it is. Example 6 from page 233 of the book you guys don't read. Let's see here, example. I'm just messing with you. To example 6. Page 233 of your electronic book, so whatever page means. So you got a Coast Guard patrol boat travels 4 hours on a trip downstream. 4 hours downstream. There's a 6 mile per hour current. And the return trip takes 5 hours. Find speed of boat. So he says the distance is equal to the rate of the, he calls VB R. All right, so R plus 6 times the time, which is time downstream 4, right? But the distance on the return trip, right? It takes 5 hours, right? So R minus 6 times 5. So then, of course, this gives us what? 4R plus 24 is equal to 5R minus 30, which gives us to 54 equals to R. So apparently, the velocity of the boat, 54 miles per hour in this case. Wow, that's really moving. I don't know if I want to go 54 miles an hour on a river. All right. So distance is time times the rate. 4 plus. Oh, I see. My mistake. So what I should have done is, oh, goodness gracious. So embarrassing. They should take my master's in physics away from me. This should be VB minus VR. That was my mistake. Because it's 49 miles in the other direction. It's just a question of directions. So it should be the velocity of the boat minus the velocity of the river, which is still a positive number, right? Otherwise, it's not actually happening. So instead of having, so I'm supposed to have VB minus 4. All right. I'm trying to find all the offending ones. Right. Let me just. All right, so we get 98 over VB plus 4 equals 49 over VB minus 4, which gives me, I'm gonna work it over here. 98 times VB minus 4 equals to 49 times VB plus 4, which gives me 98 VB minus 196 equals to 49 VB plus 196, which then gives me 98 plus 49 is what, 147 VB equals to, whoop. Oh no. Oh, what have I done wrong? Oh, yeah, duh. Negative 3, I'm sorry, my bad. Minus 392. And the same over here, right? But I mean, 4 times 49, I'm an idiot. That one is, that's 196, all right. So 196 plus 392, well, I say, so I do get the 140, wait a minute, no. Oh, man, is there anything, can I do anything right today? Let's see here, So 98 minus 49 is what? 49 VB, right? Equals 196 plus 392, which is what? No, 196 plus 392. 400, 500. What is it? Oh, 588. I'm sorry. You said it. My brain skipped or something. So we got VB, finally, is 588 divided by 49, which is 12. So there you go. 12 miles per hour, which is, in fact, the answer in the key. Okay, so my mistake was small, but nevertheless impactful, right? So VB minus VR is what I should have there. Otherwise, if I did it the other way, it would be negative, right? Think about it this way. If the velocity of the current is larger than the velocity of the boat in still water, the current sweeps the boat away, right? And so it doesn't make sense. But anyway, sorry about that. Would you like to ask me a non-word problem? Yes.
That's the only ones I've struggled with in homework.
Yeah, well, it's understandable. They're kind of tough. I do better with the problems that are about cars and cars catching other cars. For me, that's just easier to think about. I don't know why. Like the boats, stick with the coins. The coins and the ink cartridges. Yeah. Okay, sure. The graphing. Like when you're given a graph or how to graph?
Like when I'm giving graph like number 7. Wait, yeah.
Well, 7
How do I?
7 is easier, I think. Wait, 7. Oh, wait, I'm sorry. I was looking at the answer for 7. Let me find 7. My pages are all out of order. Give me a second. I'll find it eventually, you know. Ah, here we go. So here's 7. What's the question? You've got, it says, show that the two ordered pairs are solutions to the given equation, and then use the graph of the 2 points to determine another solution. Answers may vary. All right. So the equation that's given is y is equal to x minus 1, right? And you're supposed to check 7, 6, and you're supposed to check is minus 2, minus 3. Are these on the graph, right? So the question is, if we take, is 6 equal to 7 minus 1? Well, 7 minus 1 is equal to 6, right? So if we plug x equal to 7 and y equals to 6, this equation is true, right? The next one, if is minus 3, question mark, is that equal to minus 2 minus 1? Well, yep, it is, right? And then there's different ways to go about this. All right, so 7, 6 would be here-ish, right? And minus 2, minus 3 is here, kind of, as best as I can do on the chalkboard, right? So, I mean, the review sheet gave you an axis here. I guess they're kind of hoping you'll take a... see, I don't know. There's two different ways to find... The question is to find another pair that makes the equation true. So there's a couple different things. So I'm not really solving the problem at the moment. I'm just pointing out to you that this line looks like this, right? So that's the graph of y equals to x minus 1, right? Did the problem ask you to graph? It didn't, did it? Did it?
He said then use the graph of the 2 points to determine another solution.
Oh, okay. See, well, fine. I would just think the question would be more natural if they said use the graph of the line going through these 2 points to find another solution. That, to me, that question would make more sense, So if we made this line very carefully, that's not a word, carefully, then any point on this line corresponds to a solution to the equation, right? But there's literally an infinite number of answers to this question. Like, you can put whatever you want, really. So, all right, so let's think about it this way. So we want another point. We want another solution to y equals to x minus 1, right? So how about this? Let's put x equal to, there's only 2 things I can't do. I can't do minus 2 and I can't do 7. Those are already taken. Give me any other number. Any number. Just I don't want to do the ones we already did that were given. Minus 2 and 7 are out. Other than that, 5? Just one number, though. If 5 is x, what's y? It's right here, right? Now, I don't know about you, but I can't really see what the value is for the y coordinate of that point. But I could figure it out because this is the graph y equals x minus 1, right? So if x is equal to 5, y has to be equal to 5 minus 1, so 5, 4. Oh, you were telling me 5, 4 was on the graph. Stuart, you're telling me 5, 4 was on the graph?
I just said 5, 4.
You just said 5, 4?
Was it on the graph?
You are very lucky. 5, 4 is on the graph. You should take the test today.
I kind of wish I could.
I mean, I feel like you've got some kind of like, well, I saw you do something with the rodeo. You guys have, there's like lucky, you just go to graphs.
I can look at one test corrections.
So 5, 4 is another point on the graph. Another thing you could do, here's another point. If you look at where x equals to 0, 0 minus 1 is on the, how do I know minus 1 is on the graph? 0 minus 1? Because this is slope 1, y-intercept minus 1, right? So I can tell you this is a point on the graph. I mean, as it said, answers may vary. There's not just may vary, like there are infinitely many answers to number 7 for the other solution. I tend not to ask this question on tests that much because it confuses students, because it's just like, it's so open-ended, you know? Is there another one you'd like to look at? Want to look at graph the linear equation number 9? You finding that? We should do that one, number 9. You're asked to graph y equals to 2x plus 2. So how do you graph a line? Well, one way we could graph is just to find 2 points on the line. We could use the idea of the previous problem, right? So how about x equals to 0? What's y equal to? Y equals to 2, right? So therefore, 0, comma 2 is on the graph, right? So where is 0, 2? 0, 2 is, say, here, right? How about y equals to 0? Where would that be on the graph? 0 is equal to 2x plus 2. What's that make x equal to? See, if you solve for x, you get x equals to minus 1, right? So another point on the graph would be minus 1 comma 0. That's also a point on the graph. So that would be here, you know. Now, picking a y value is kind of a pain, right? Because we had to solve for x. What could we have? What could we could have alternative? I can't say words today. Alternatively, we could have put x equal to 2, right? X equals to 2. That would give us what? Y equals to 2 times 2 plus 2, yeah? Which would have been 6. So we could have learned that 2 comma 6 is on the graph, right? Which is kind of hard for me to, it's kind of like up here. You notice that when I put x equals to 2, I don't have to do algebra, I just plug the number in, right? When I put y equal to 0, that forced me to do a little algebra to figure out x equal to minus 1. My point to you is, did we need 3 points? Well, we did not need 3 points, right? Once you have 2 points and you got a ruler, you're good to go, right? Because 2 points determine the line, right? So I would encourage you to bring a ruler to your test, you know, for best results. And I don't mind you guys sharing a ruler. If one of you has the other, you don't mind sharing with other people, I don't mind at all. It's hard to cheat with a ruler. Now, what's the other way we can graph a line? The other approach we could have taken here, I'll just do an example. Graph y equals to, let's say, 3/2 x minus 2. So I look at this, I can tell two things from this. Right. This has y-intercept minus 2, right? And what's the slope? 3/2, right? That's the coefficient of x is the slope. So that means that in the graph, we go rise over run is 3/2, right? Or change in y over change in x, right? So here's one point on the graph, the y-intercept, right? Then what am I going to do? I'm going to go up 3, 1, 2, 3, over 2. So that gives me this point, right? And then I do it again, rinse and repeat. I go over 2, I go up 3, yep.
So why did you choose those places?
Chose what place?
Like the last point, how did you get there?
This point right here?
The last one.
Well, that one. So each time I'm thinking about a little triangle where I'm going over 2 and up 3. I'm going over 2 and I'm going up. I can't. It was red. I guess it's more like here, right? So you can always like rise, run, right? I mean, other way around. Run, rise, run, rise. And so, of course, the triangle, the line that we're trying to graph is this thing, right? Now, I personally think it's easier just to find 2 points and use a ruler, as opposed to finding 1 point and then using the slope to kind of like go from there. But people do both. I've done both in the past as a student. Both ideas are useful, you know. You can check yourself, right? So this is 1, this is 2, right? What happens when I put x equals to 2? I should have y equals to what here? 3/2 times 2 minus 2, which is what? 3 minus 2, which is 1. And check it out. That is where we got to, right? This point right here is 2, 1. So we can check. I can check my building the line from slope idea against, if I plug in that 2, do I really get 2, 1? Well, yeah, I do. So if you haven't, I encourage you guys, make sure you've, studied the videos that we've had the last week. If you've been missing, make sure you can do all the homework problems. And if you can do the review questions, you should be pretty well off Friday. Oh, I'm sorry. I seem to have gone over a minute. My bad.